Is there any other question you want me to go over from here? 1.7?
I was thinking possibly number 22 or 24.
Let's do both. Why not?
Okay.
Number 22. This guy, this one I see it, I know it's divergent. One over 2 plus sine k. Now, why I say this is divergent? Because 2 plus sine k is less than equals to 3, but still greater than 1, right? Such that the reciprocal, actually I don't need that absolute value, such that the reciprocal will be bounded above by 1 over 1, but bounded below by 1 over 3. Right? What I need is the bounded below. Like this. But this is constant, right? This is divergent. Do you know why this is divergent?
Because you're always adding 1/3, 1/3.
Yeah, yeah, is divergent because let me just say that Bn actually convergent, not convergent to 0, right? The Bn is always 1/3, which is not convergent to 0. So by comparison test, this series is divergent as well. Okay, that's for number 22, not too hard. Number 24, this one is sneaky. It's divergent by divergence test. Thomas, how can you tell by just looking at that? Keep in mind, the first thing you actually do in all your tests, pretty much, if you don't know what to do, like sometimes when you see it, you know it, right? But if you don't know what to do, check what happened with the last term first, like the end term. Okay, so how do I show that? I will do it this way. Let fx equals to x sine 1 over x. Now I want you to see that this guy here, this guy, this actually convergent to 1. How do I know? Because if I rewrite it as this, right? Limit n goes to infinity. Actually, I don't need that. I don't need that. Actually, I'm working too hard. My bad. This is all I need to say actually. Limit n sine 1 over n. I thought I need to do L'Hopital rule, but it turns out I don't need to. So this is sine 1 over n over 1 over n. Okay. And I want to say that this goes to 0, but how do I argue? When n goes to infinity, This is when n goes to infinity. Yeah, but when n goes to infinity, then 1 over n will go to what? Go to 0 positive, right? So if I change my 1 over n to be, let's say, x, for example, then it will be limit x goes to 0 positive of sine x over x. But we know that's equals to 1. It doesn't go down to 0. So by divergence test, see, the sequence is convergent to non-zero, such that the series is divergent. Okay, and I want you to realize that I can easily change this to tangent, and it still works the same way. You see what I mean? Okay, because tangent x over x gives you 1, okay, when x goes to 0. But when x goes to infinity, that's not true though. Okay, when x goes to infinity, that's not true. Other question? No more? Okay, I go on to 11.8. This is called power series. So 11.8 power series. Did I record it yet? Yeah, I'm recording it. I will start with definition. You remember what we call a power function. Power function is a function f(x) equals to ax to the n, where the n is an integer. Actually, positive integer to be more precise. Okay, that's the notation for positive integer. Now, then, power series is the series of power functions. Power series is the series from n equals to 1 or maybe 0 in this case, okay, of such power functions. Okay, let me use a sub n x to the n. Now, our textbook use c instead for the coefficient. I will follow the textbook. Okay, I will follow the textbook. Let me do some adjustment. Instead of using coefficient a, I will use coefficient c. Okay, which can be written as c0x to the 0 plus C1x to the 1, C2x squared, all the way to infinity. Okay, now convention. In power series, we adopt this fact that x to the 0 is equals to 1 even when x equals to 0. Basically, power series is polynomial. Because power series is polynomial, then the domain is all real numbers. Okay, but we have issue when x equals to 0. And when x equals 0, then what happens 0 to the 0? So 0 to the 0 is supposed to be undefined. Okay, supposedly. Now, however, using this convention, with the knowledge that a polynomial has domain all real numbers, right? Such that we fix this discontinuity by defining, we redefine it as one. Okay, which is actually not true in general. That's not true in general. Okay, so power series basically the summation of power functions. Okay, infinite series of power functions. Now, one of well-known power series, of course, something you have seen before, and this is the example in our textbook. This series here, x to the n equals to 1 to infinity. Now this is, I'm sorry, from 0. So x to the 0 is 1, x to the 1 is x squared plus x cubed, and on. Now, we notice that this is actually also a geometric series, right? This is 1 over 1 minus x, okay? As long as when the absolute of x is less than 1. Remember that? Okay, which means x has to be between -1 to 1. Okay, and divergent when absolute of x is greater equals to 1. What we will do here is we will observe some power series and see for what values of x will the series be convergent, and of course for other than that it'll be divergent. Okay, like what we have seen in this example 1 here, if I write it in a nicer way, so this is equals to 1 over 1 minus x is divergent. There are two possibilities. Okay, now it's convergent to 1 over 1 minus x for absolute of x is less than 1, and divergent for absolute of x greater equals to 1. Okay. Now, in this section, maybe I write it here. In this section, we will see the following. We will see that a power series may be convergent when, I think I want to say only when a x equals to 0. Actually, I missed something. X equals to a. X for all x. And the third one, absolute of x minus a is less than r for some r. Some positive number r. I forget something. My bad. I forget something. I need to say this first. Let me lasso it. I forgot to say what kind of power series we're dealing with. Okay. I need to define one more thing before I talk about that. Definition. Power series in x minus a or power series about x equals to a or power series centered at a is the power series n equals to 0 to infinity of Cn x minus a to the n. That's the definition. I want to quote from here. You see what happened here? This is our power series, right? Okay. Now replace this x here by x minus a. Replace that x by x minus a. Okay. So this is our original power series, right? Okay. Now replace this x by x minus a. Which, if you think about that, that's basically moving the graph of the functions to the right by a units. Okay, now that's why then you see they change the wording. It's like in x minus a instead of in x, about x minus x equals to a, or when you center it at a. Okay, now that's the power series centered at a. I usually just say power series about a. That's what I usually say. Now, the thing is then this power series, let me continue here. Ooh, no, that's not what I want. Let me redo it then. This power series has only 3 possibilities for convergence. First one, it's convergent at x equals to a. In fact, when x equals to a, you see that you end up having this. That's basically the series of Cn times 0. That's the summation of all zeros. That's always 0. Notice that it is always true. Okay? Any power series like this, will be convergent when x equals to a. Okay? Now, the thing is, it may be convergent also in other situations. Convergent at all x. Convergent at all x. Now, I can show you, later on we will work on examples that give us this situation. But the third possibility is convergent when that absolute of x minus a is less than some r and divergent when the distance of that x from a is already greater than r. Okay? So if I try to picture that, the first possibility is it is convergent only at that a, only convergent at that a. Only convergent at that a. That's one. The second possibility, it is convergent at any real numbers. It's convergent at any real numbers. Now the third possibility, it is convergent at some distance from a. So let's say this is a, you go to the right and to the left by r units. Okay, it's only convergent here. And outside of this interval, it will be divergent. Okay, now basically this theorem, this rule says the following. It is impossible for us to have the convergence like the following. Like this is A here, and then you go 10 units to the right, and you go 5 units to the left. No, it won't happen. It won't happen. The number of units it goes to the right will be the same to the number of units it goes to the left. Okay, now this R here, later on will be called radius of convergence. Such R, maybe I use this guy. Such R is called radius of convergence. Okay, which if I solve, then I will get x minus a is between negative r to r, x is between a minus r, a plus r. At the endpoints, at a minus r, this endpoint here, n at the other endpoint, a plus r, we will observe, we will observe the convergence specifically. Okay, so at the end, in case part C here, we will get at the end the interval of convergence, the interval of convergence is one of these. It's either a minus r to a plus r, including both endpoints, or including left endpoint, or including right endpoints, or not including any endpoints. Okay, now what we will do in this section is to find the radius of convergence. We will practice using some problems first. Let's take a look on page 769. Page 769. I'm actually done with this section. That's all you need to know. What we are going to do is to practice this on problems. Let's say, for example, on page 769, I do number, which question is good? Maybe number 6. I do number 6. Find the radius of convergence and interval of convergence of this series. Find radius of convergence and interval of convergence. Okay, for the series of -1 to the n, x to the n over n squared. Now, in our previous sections, the question were to decide if the series is convergent or divergent. Now, the question will be, at what x will the series be convergent or divergent? Now, we remember we have many tests that we can use. Okay, one of the common tests being used here is ratio test. Okay, now the thing is, this series can be convergent, can be divergent. We don't know. We don't know. Okay, we don't know. But I will try to put that under ratio test. By ratio test to see what kind of x will make this series have what kind of x will make the ratio to be less than 1, because for ratio test the series will be convergent if the ratio is less than 1. Okay, so by ratio test I get -1 to the n plus 1 x to the n plus 1 over n plus 1 squared times the reciprocal -1 to the n x to the n and x squared here. Okay, that's the ratio. which will be, this is equal to x times n squared over n plus 1 squared. Is it right? Which is equal to absolute of x times, the thing is this guy here is non-negative, right? So I don't need absolute value for that. That will be n over n plus 1 squared. That's 1 over 1 plus 1 over n squared. Are you following me? Yes. Okay. And then this guy will converge to absolute of x when n goes to infinity. Right? Now, but for this ratio test to be successful, to make it convergent, the limit L has to be less than 1. Okay? So the series is convergent. That's convergent when absolute of x is less than 1. Okay? So therefore, we then say the radius of convergence is equal to 1. This one here. Notice that this is a series centered at 0. This is a series centered at 0. So you want this guy here to be absolute of x minus 0. Okay? Now then the radius is the one here on this side. In other words, I'm saying the following. You cannot read the radius. You cannot read the radius if you have, let's say, x over 2. You know? Now, let's say we have like that. Now, this is not the radius. You have to rewrite this into absolute of x less than 2. Then this is the radius. Okay? So inside that absolute value, right before you read the radius, inside this absolute value here, okay, it has to be x plus or x minus some number. Cannot be something x. No. It has to be x plus or x minus some number. Then the number on the other side of the inequality is your radius. Okay? So that's the radius of convergence, which implies that x is convergent, for sure is convergent when x is between -1 to 1. Okay? Now, however, we need to know what happened when x equals to 1. When x equals to 1, will that be convergent? So I come back here. Okay, I come back here. And then I put it here. Ooh, no, it doesn't place. Let me just write it down. When x equals to 1 and equals to 0 to infinity, actually 1 to infinity of -1 to the n, and then 1 to the n. So I replace the x equals to 1 now here. Okay, x equals to 1 now there, over n squared. Is it okay? Which is equal to infinity with 1. -1 to the n over n squared. Is it right? Yeah. How do we show that this is convergent?
You can take the absolute value.
Okay.
And then
you can take the absolute value.
P series.
So consider the sum of the absolute value this is convergent by P series P equals to 2. That's right. So in fact, we can say more. So that series earlier is absolutely convergent. Is it right? As if I'm saying that actually I can just use plus minus 1 here. Is it right? You see where I'm going? I try to combine two arguments into one, but I guess that could be confusing. Let me just leave it like that earlier. Let me just leave it like this for now. Okay, so this guy is convergent. Okay, now at x equals to -1, we get this series n equals 1 to infinity of -1 to the n times -1 to the n. But that the second -1 actually coming from here over n squared, which is equal to, let me do below, what happened on the top? We get -1 to the 2n, is it right? Which is 1 over n squared. That is convergent by P series. P equals to 2. So you notice that at x equals to 1, it is convergent. At x equals to -1 is convergent. So interval of convergence, the interval of convergence, originally -1 to 1, right? But we also find out that it is convergent at 1, convergent at -1. Are you following me? So it will be convergent at -1 to 1, including both endpoints. Okay, now that's for this number 6. Let's do more. Let's do more. Would you like to choose any problem? How about number 12? 12. I asked you to choose, but I end up choosing it myself. Okay, you start looking around. Okay, start looking around. So my series is the series from 1 to infinity of x to the n over n times 3 to the n. So I will try to squeeze that using ratio test so that I can see at what axis it will be convergent. So a sub n plus 1 over a sub n is equal to x to the n plus 1 over n plus 1 times 3 to the n plus 1 times the reciprocal which simplifies to be x over 3 times n over n plus 1. N over n plus 1 is positive definite, especially when n is starting from n equals to 1, right? So I just need to use absolute value on absolute of x over 3. And this guy here, I will work on the limit. So this is absolute of x over 3, 1 over 1 plus 1 over n. Let me use parentheses so that you can better see the separation, which goes to absolute of x over 3, right? And when is this convergent?
If it's less than 1.
And that guy is less than 1. This is convergent when absolute of x over 3 is less than 1. Therefore, absolute of x is less than
1/3. Oh, sorry, 3.
multiplied by 3, right? Okay. So radius of convergence is the r. Let me just call it r instead of arrows. ROC. Radius of convergence is equals to 3. Okay. Now we get the interval. So x will be between -3 to 3, right? It will be convergent here. Now need to check the convergence at the endpoint. At x equals to -3 and at x equals to 3. Okay, let's see. At x equals to, let me do +3 first. And x equals to +3, I get the summation and it goes to 1 to infinity of 3 to the n over n3 to the n. My 3 here, replacing that x here. This is equal to the series from 1 to infinity of 1 over n. Right? Maybe I write it this way just to make you happy. 3 over 3 to the n, which is 1 over n, 1 to the n. Is it better? Come on, man, you're in half 2.
That's fine.
Right? Okay. And then, but what can you say about this series?
It's divergent
Why?
because well, P series P is equal to 1.
Can you give me a better name for than that?
Better.
Harmonic series?
Oh, it's the
Yeah,
harmonic
because
series,
it's a harmonic series. Okay. Now what happened at x equals to -3? I replace that x by -3. get the series from 1 to infinity of -1 to the n over n. Is that right? Which is convergent because
It's an alternating harmonic series.
it's alternating harmonic series. Yeah, they actually appear a lot such that we give them special name. And another reason is because we use that also a lot here. Okay. Then so this series, the interval of convergence, the interval, how did I write it up there? So interval of convergence will be the interval from -3 to 3 union -3, right? And therefore the interval of convergence will be -3 up to 3, but not including positive 3. Now, let me copy paste this problem here and I change it a little bit. So for example, I change the question to the series from 1 to infinity. Now, instead of x, I make it, let's say, x minus 5 to the n over n times 3 to the n. Notice how I replace the x becomes x minus 5. Okay, now I will go over the procedure all over again. Basically, you will see I do the same thing what I did in number 12. I hope then you see how these things actually behave when I replace x by x minus 3. You will see this interval later on, actually move by 5 units to the right. It becomes from 2 to 8, like that. Okay, because you basically move the series to the right 5 units. Okay, but let's confirm. We want to find out why that's true. Now, the radius of convergence, you will see still hold to be 3. Solution. The next term over the current term, that will be x minus 5 to the power of n plus 1 over n plus 1 to the n, and then n times 3 to the n, actually this is n plus 1, over x minus 5 to the n. Furthermore, I will get absolute of x minus 5 over 3 times n over n plus 1. Fast forward, I will see that this is convergent to x minus 5 over 3 as n goes to infinity. My root test, my ratio test, not root test, ratio test, it's convergent when is absolute of x minus 3 or minus 5 over 3 is less than 1. Therefore, absolute of x minus 5 is less than 3. Radius of convergence is still 3, right? You see? And then we go on, this is -3 less than x minus 5 less than 3 plus 5. So this is 2x, this is 8. Right? Now we need to check. Need to check the convergence at x equals to 2 and x equals to 8. Okay, so at x equals to 2, the series then becomes 2 minus 5 to the n over n times 3 to the n. I hope you see some pattern already, right? So this is an alternating harmonic series. This is convergent by alternating harmonic series. And when x equals to 8, simplify, I get 3 to the n over n times 3 and that's the harmonic series. By harmonic series. So the interval of convergence now is between 2 and 8 union one of the endpoints. Which one? 2. Right? So the interval where it is convergent is 2 to 8, including 2, but not including 8. Okay? But basically, that's how we check them. That's how we check them. Okay, we find the radius of convergence first. Using that radius of convergence, using this radius of convergence, that we get the basic interval. Then you check the endpoints. Okay, then you check the endpoints. That's the plan. That's the strategy. That's what we will do. Now, I'm done with number 12. Now you choose a problem.
Could we do 20 and if time 28?
Number 20. Let me do number 20 first.
Mm-hmm.
So the series from 1 to infinity of 2x minus 1 to the n over 5 to the n square root of n. Okay, by ratio test. That will be 2x minus 1 to the n plus 1 over 5 to the n plus 1 square root of n plus 1 times the reciprocal 5 to the n square root of n 2x minus 1 to the n. Simplify, that gives me 2x minus 1 over 5 and square root of n over n plus 1. Right? When n is 1 and on, this will be positive definite. So I don't need an absolute sign for that. Right? So this is equal to absolute of 2x minus 1 over 5 square root of n over n plus 1. Of course, I still need to do that routine. That's square root of 1 over 1 plus 1 over n, which will converge to, this will converge to 1. This will go to 1. Right? This will go to 1. So the whole thing will go to absolute of 2x minus 1 over 5 as n goes to infinity. Then my ratio test, this limit is supposed to be less than 1. Okay, which implies absolute of 2x minus 1 is less than 5, right? But we are not done yet though. We are not done yet. This power series is not centered at 1. No, it's not centered at 1. It's actually centered at, you need to divide this by 2 further. It has to be x over something, x plus or minus something. So this will be 2 times x minus 1/2. Is that right? Oops. So absolute of x minus 1/2 is less than 2.5. That's the radius of convergence. Okay, that's the radius of convergence. So radius of convergence is 2.5. Now, how about the interval of convergence? Let me pick it up from here. It will be from -5 less than 2x minus 1 less than 5. I add 1 divided by 2. Now then we check at -2 and at 3. Now check the convergence. Convergence at x equals to -2 and at x equals to 3. Now let's see at -2 first. At x equals to -2, at x equals to -2, the series will be 2 times -2 minus 1 to the n over 5 to the n square root of n. This is the series -5 to the n over 5 to the n square root of n, right? Which is alternating series, huh? Now, how do you do? If I have alternating series, this is P series, huh? Is that right? This is convergent. There's a convergent because it is alternating P series. Where P is greater than 0. As long as it is, as long as the power is positive, then alternating P series will be convergent. At x equals to 3, let's see what happened. So that's 2 times 3 minus 1 to the n over 5 to the n square root of n. Simplify. That becomes 5 to the n over 5 to the n square root of n. That becomes 1 over square root of n, which is Convergent or divergent?
Divergent.
It's divergent. Why?
P is less than 1.
P series. P is less than 1. Okay. P is 1/2, right? P equals to 1/2, which is less than 1. Maybe I actually supposed to say this one. Okay, and then you say number 24. Ooh, that's hard. The series is so hard to express even using some general term. N squared x to the n over 2, 4, 6 all the way to n. Actually, they can express it that way. Just let you know that this series, this sequence here, 2 times 4 times 6 times 8 all the way to 2n, we can factor 2 actually. There will be 2 to the n times 1 times 2 times 3 times 4 up to n. Is it right? So this is actually 2 to the n times n factorial. Just let you know. Okay, this one happened to be not too hard to do. Most of there are times that it's not doable though. Okay. Well, anyway, I go back to the ratio test. So by ratio test solution. The next term will be n plus 1 squared x to the n plus 1 over 2 times 4 times 6 all the way to 2n. The next one will be 2n plus 2, right? And then 2, 4, 6 all the way to 2n only over n squared x to the n. Simplify, I get x over, no, only x, huh? Only x, and then for the n part will be n plus 1 over n squared times 1 over 2n plus 2, which is equal to absolute of x, right? And this guy here, I will make it 1 plus 1 over n over 1 squared times 1 over 2n plus 2. Now, this guy will go to what when n goes to infinity? Will go to 1. Okay, so it will go to 1. We'll go to 1 here. Oops. We'll go to 1 here. How about this guy? When n goes to infinity, what will that be? Zero, right?
Yeah.
As n goes to infinity. Okay, now then the whole thing will be equal to 0 then, is it right? Now then by root test, by ratio test, not root test, by ratio test, therefore this a sub n plus 1 over a sub n, which is convergence to 0, is always less than 1 already. right? It's already always less than 1. So what is the radius of convergence?
1.
The radius of convergence is infinity.
Yeah.
Okay, now that's actually the second case we have up here. Where's that? Where's that? Here. That's convergent for all x, which means the radius of convergence is infinity. This is when the radius convergence is 0. Okay, now once the radius of convergence is infinity, then the interval of convergence will be
Negative infinity to positive infinity.
correct, which is basically all real numbers. Okay? In other words, this series, therefore, is convergent whatever x you put. Oh, not this one, huh? Not this one. This one, number 24. Yeah, whatever x you put there, it will be convergent. Okay. That's number 24. With the time I have left, let me take around 10 minutes here to do some conceptual problem. Let's take a look on number 29. Let's take a look on number 29. That's an odd number, I know. If the series Cn 4 to the n from n equals to 0 to infinity is convergent, suppose that's convergent, then what can you say about radius of convergence? Let me say the following. If this is convergent, means it means 4 is inside the interval of convergence, right? Does it make sense?
Is this like the example of the first, like the A, I guess, where you said it's 0 from like the identities, if you could call it like that?
The way I want you to see is actually in this sense here, that it follows this power series. So if when x equals to 4, it is convergent, means the interval convergence containing 4. You see?
Yeah.
Okay. Okay. But then on the number line, this series here is the series centered at 0. And when it is at 4, it is convergent. It implies the radius of the convergence, the radius is at least 4, right? It's at least 4, maybe more. Okay, where now it means then everything between 0 to 4 and 0 to -4, not including the endpoints, though we don't know about the endpoints. Now everything here must be convergent. So when x is between -4 up to 4 is guaranteed. Guaranteed convergent. Okay, now then on the options there, when part A, will this series be convergent? Will this series be convergent? Will this series be convergent? And the answer is yes. It will be convergent. Why? Right, because 2 is in that interval between -4 to 4. Okay, now how about at -4? How about at -4 for part B? The answer will be maybe not. Okay, because from what we have here, we only know that the radius is convergent is at least 4, including 4, such that the interval of convergence we know will be from -4 to 4 only. And simply because we know it's convergent at 4, then we get that endpoints. Okay, but the other endpoints is not guaranteed. Okay, the other endpoints is not guaranteed. So -4 may not be in the radius, may not be in the interval that we know for sure is convergent. Okay. Yeah, I see that from the power series centered at origin. Let's see number 30. Number 30, suppose the series Cn x to the n is convergent when x equals to -4, but divergent when x equals to 6. Let's take a look on that question. Try to draw the number line at which the then try to kind of like imagine what kind of axis will that be convergent. So let's say this is the number line. Okay, at -4, it's convergent. At 6, it's divergent. This is convergent here, this is divergent here. Okay, so we are guaranteed that it will be convergent here between -4 up to 4. This is surely convergent. Okay, that's surely convergent You see, it's centered at 0, right? Centered at 0. Now, then, from -6 to the left here, this is convergent here. Now, because it's at when x equals to 6 is divergent, then everything there will be divergent. And everything to the left of -6 for sure is also divergent. Now, we don't know what happened at -6 though, just like we don't know what happened at 4. Okay, the question mark is when your x is in between here, we cannot say anything. Okay, we cannot say anything. Okay, we also don't know about the endpoints here. We also don't know about the endpoints there. Okay, so maybe I write it this way in some small summary. Surely convergence on this interval -4 to 4. Okay, surely divergent on -infinity up to -6 or 6 to infinity. Okay, the rest we don't know. Now then, part A. Part A, how about the series Cn? Will that be convergent?
No, it's just adding a constant. Cn on its own would just be adding a constant, right?
I think
Yeah.
it's convergent because it'd be 1 to the n.
Yeah, that's 1 to the n.
Oh.
Right. But your argument, the sum of constants, this is not a constant all the way, right? This is Cn, which means it gives you a series, right? It gives you a series, but this series may be following, for example, a geometric series though. Okay. Yeah, so Cn there is basically 1 to the n, okay? Which means the x is equals to 1, right? Okay. But when x equals to 1, it is in the interval. So it is guaranteed to be convergent. Okay, part B. What happens if I have the series when I want to infinity of c and 8 to the n? The thing is, x equals to 8 is in that interval here, in this interval, right? So it will be divergent. How about the series Cn -3 to the n? X is -3, which is the inside the intervals of convergence. So that will be convergent. How about part D? That's -1 to the n, Cn, -9 to the n, or 9 to the n, not negative. And that will be Cn -9 to the n, is that right? So the x is -9, which is in this here. Actually, to be precise in this. okay, such that it is divergent. So this series is divergent. Okay, that's where I will stop for now. Suggested homework from this section is this 11.8 will be number 3 to number 7. Okay, right now it's 6 o'clock. Let's take a break for, thank you. And not too much, right? Okay, so far we're still going on with what we know. Then we will do substitution. We will do substitution. Suppose we have this kind of series. Suppose I have the series. Suppose I have the series of, let's say, negative x squared to the n. Notice that you see that it actually matched the pattern x to the n, and this is blah to the n. Is it right? Okay, is it right? So then I can represent this series by 1 over 1 minus negative x squared. You see that? Okay, which is 1 over 1 plus x squared. Yeah, of course, as long as for absolute of negative x squared has to be less than 1, right? So as long as that guy here, this guy here, has to still be, the absolute value still less than 1. Can you follow me so far? So that's the first example though. That's for the first example. Another one, for example, suppose, so you need to see patterns. Suppose I have the following. Suppose I have the following 1 and then minus sine x plus sine squared x minus sine cubed x plus sine to the 4th x, so on and so forth. Now then notice that this can be written by summation notation n equals 0 to infinity of sine x to the n. Is it right? Is it okay? Now
Yes.
then this is equal to what? What function it represents? It represents 1 over 1 minus sine x. My bad, I miss a negative sign here. I miss a negative sign. I miss a negative sign here, is it right? So it becomes 1 minus negative sine x. For absolute of negative sine x less than 1, or basically saying absolute of sine x is less than 1. Okay. And we have more. We have more. Another example. Find the power series representation of 1 over, let's say, x plus 3. I need to catch this pattern or something 1 over 1 minus something. I need to catch that pattern. What should I do here? Let me see. I can rewrite this as 1 over 3 plus x, and then factor that 1/3 out. So I get 1 over 1 plus x over 3. Is it right? So now I can represent this as 1/3 the series from 0 to infinity of negative x over 3 to the n. Right? Again, for absolute of negative x over 3 to be less than 1, or basically the radius of convergence is 3. Okay, we can clean this up, show that this is actually an alternating series. This is negative 1 to the n, x to the n over 3 to the n. Let me move that 1/3 in. So this is the series from 0 to infinity of negative 1 to the n, x to the n over 3 to the n plus 1. Okay, now continue from that example. Continue from this example here. Suppose I have instead, let's say x cubed over x plus 3. Well, we see this as x cubed times 1 over 3 plus x, right? But this thing here already done earlier. This thing is something we already done. So this is equal to x cubed times the series from 0 to infinity of negative 1 to the n, x to the n over 3 to the n plus 1, which I can push the x cubed inside x to the n plus 3 over 3 to the n plus 1. Okay, one example from number 10, let's say. One example from number 10. Find the power series representation for fx equals to x squared over a cube minus x cubed. So try to massage this, I will see this as x squared, and I factor a cube out. That way, then I get 1 over 1 minus something. Is it right? Now then, this is the thing I develop further as the power series. So I get x squared over a cube, the series from 0 to infinity of x over a cube to the n. Okay, so this is x squared over a cube, the series from 0 to infinity of x to the 3n over a to the 3n. Now I will push this a squared a cubed in. So that becomes a power series of x to the 3n plus 2 over a to the 3n plus 3. Okay, now how about the interval of convergence? The interval of convergence will be absolute of x cubed over a cubed is less than 1, which implies absolute of x is less than absolute of a. Okay, so the interval of convergence will be at least from negative absolute of a to positive absolute of a. Then you can observe what happened when it is equals to absolute of a. When it is for x equals to absolute of a, then we will get, let me continue from here. X squared over, I'm sorry, not yet. I need to come from the function. So f absolute of a, the thing is I don't know if my a is positive or negative. That's why I use absolute of a to make it positive. So this is absolute of a squared over a cube minus absolute of a cube. I think if they are the same, let me use a instead. So I don't need the absolute sign here. When it is a, this becomes undefined. So there's no function actually to represent that. There's no series to represent that. Okay, when x equals to negative a, however, I will still get a squared, but at the bottom, I will get 2a cubed. That's 1 over 2a. Right? Now the thing is it true that I will get 1 over, I'm sorry. Is it true that this is negative a squared over a cube series 1 over 1 minus negative a over a cube? No series. I get no series. So this is equal to negative 1 over a times 1 over 1 plus a. 1 plus 1. It's negative 1 over 2a. No, it's not true. It's not true. Because it will give us negative. So the interval convergence will be only, interval of convergence will only be negative a to a. Okay, but actually I need to see what happened on the right hand side. Well, anyway, let me put question mark here. The time's up right now. Let me put question mark here. I wonder if I miss anything. I made mistake here. This is not negative, that's positive. That's positive, so it's actually true. They're equal. So it's convergent here. Good thing I look at that again. But the one I'm supposed to check is I'm supposed to check with this though. I'm supposed to check with this. This is what I'm supposed to check with. Yeah, this is what I'm supposed to check with. With which, in my opinion, it's supposed to be not convergent. I'm supposed to check with this. My bad. I'm supposed to check not with this one, but supposed to be with this one, with the series. So because we have no problem from here to here, that one is okay. From here to here, we have that. That's the one in question. Okay. So sorry. So the one. Give me one more minute. I just want to finish this one question. So I need to check if this is true. That let me copy paste this one here. The one that I have here. Is it true? So negative a to the power of 3n plus 2 over a to the 3n plus 3. That will be the series of that will be 1 over a, from n equals to 0 to infinity with negative. But this is divergent. Right? It's divergent. Yeah, so interval of convergence is only not including the endpoints. Okay. Well, I will continue on this on Wednesday. So suggested homework for now. Suggested homework for now will be number 3, number 5, 7, 9, and try to do number 11. Yeah, try to do number 11. So 3 over x squared minus x minus 2. You complete the square. Minus, what's that, 9 over 4, I guess. So you then factor 4 over 9 out, and 3 out, 1, and you will get negative here, 1 minus 4 over 9x minus 1/2 squared. So this will be your quote-unquote x later on. Okay, that's the main part that we will need to do right now. On Wednesday, I will continue from here. Okay, on Wednesday, I will continue from here. Basically, what we'll do from here is we integrate, we differentiate whatever we have done. Okay, that's for today then.